This is the Anker PowerHouse II 800, and it has stopped working. It rained this morning quite a bit, and it was near a window, and it just apparently got the whole thing wet. I didn't see it. My partner caught it. She cleaned it all off here, and apparently it didn't get down the sides very much, but it was all over the top. I'm not sure what's going on here. If I try to turn it on, nothing happens. It was at a pretty low charge, and so I was kind of expecting that. Sometimes it'll just do this where it won't really respond at all to anything, to any inputs, and then you plug it in to charge it, and it's fine. But if I plug it in, it restarts, and then the input just flops around. It's going 9. See, it's cutting out, coming in, cutting out. So I'm stopping that right away. Just wanted to demonstrate that. Also, if I turn the output on when it was functioning, because it was functioning for a brief period of time, showing about 2% charge. If I turn on the output, it's not even letting me do any of that. It refused to power anything. But I tested it then with a really light load. It was just a 20-watt bulb, and it was fine with that, but anything more than that, it would just turn off. I don't really know what's going on here. I'm a little nervous that there might be some water inside of it. Thankfully, it's very, very discharged. It wasn't just like it might be an incorrect state of charge. I'm pretty sure it is actually down to about 2%, or at least below 10%, because I used it quite extensively. So I'm going to start taking this thing apart. I saw a comment in a video I did about the PowerHouse II 400 that it's the same steps. I'm going to try to start with that, because this looks like it's just a bigger PowerHouse II 400. So I'm going to get started on that, and then we'll see what we see along the way, and I'll take you along for the ride. All right, so that back cover came off pretty easily. It follows the same method as you would for the PowerHouse II 400. It is pretty rigid. It's definitely stiff plastic, so it's a little more effort needed to get in there. I started right around the switch. Just be careful not to pry too deep in there to typically break the switch. But I started just a little bit to the right of it, and with a pry tool like this, you just get down underneath there. Just start to pry. If it's too stiff and you can't get in there, then use something like a pick to get that started. Make sure there's enough contact area so you don't just bend the pick, and then start working across. And this whole thing popped off. So now I've got this off. The light diffuser and cover, it just slides down. You don't even need to pry, it just slides down and away, and that's it. And then there's the light bar. So now there are 6 screws on each side. Security Torx, fun, but they're all security Torx. Got my set here to get in there. So I'll remove all those, and then I'm sorry, there is more than that. There is three. There's 12. Okay, I'll get those started. Okay, all 12 screws have been removed with a socket. I recommend some sort of a socket or a ratcheting screwdriver or something like that. Don't use power tools on removing these screws, because they're all plastic, self-tapping screws, so you don't want to mess with that. This has all the screws out of it now, so this should just pull out. It's pulling out. I'm a bit nervous because last time it was just taking it apart to see what was inside, and this time taking it apart because it suddenly stopped working. Right, so I'm going to take this off. I promise I have not looked. I've got everything pried out. I just kind of saw the edges here. I'm going to flip the thing over and we'll see what we see here. I think I'm going to need to unplug this. I'm going to need to unplug this first. Okay, so there's a little connector here for this light, which I'd rather not break. And I'm going to try to do this with one hand. There's the connector. And it's just a push. That should release it. Okay, got that out of the way. Now, what are we looking at in here? It's similar to the 400. It has a lot of clearance on either side. Like, I don't know how water could have gotten all the way in there. That's a huge gap. This thing could have actually been made much smaller, or they were looking to make it a larger capacity, because that's a lot of, just all that space there. That's crazy. And is it just 2 fans? Okay, so, oh dear. That wasn't assembled properly. All right, well, here's our first concern. That was pressed right into those locking tabs. And depending on where that goes, this really seems like it was kind of stuffed together. Yeah, there's like a card here, like a fish paper. Actually, this is actually adhesive on one side that I'm guessing that they were using to keep the isolation between low voltage stuff here and this, which is the BMS wire. Like, none of this looks like it. I'm kind of disappointed so far. This looks like it was really just kind of jammed together and stuffed into this enclosure. The 400 looked like it was a much better design, or was the original design, no surprise. And they just wanted to make a bigger one, and seems like they kind of just rushed things here. So we've got some pretty heavy gauge wire coming off these battery terminals, which you'd need if you wanted to pull 500 watts. Plus a little bit of headroom there. But this is what, 8 gauge? Yeah, 8 gauge wire. Jeez. This is actually the same manufacturer, it looks like, of the battery. This is showing 760.3 watt hour, 21.6 volts DC, and 35,200 milliamp hour. I think this is actually rated at the bottom as 777. Yeah, it says 777.6. They rated it at 36,000, and this is 35,200. So a little discrepancy there in the, I don't know why they want to rate it higher, just that little amount. Okay. All right, so there's 2 Phillips screws down there holding the battery in, and I believe it holds the whole thing in, just like before. And then 2 more on this side, just above the cable for the fan. I see no indication of water inside of here. So I'm pretty sure whatever happened this morning had no bearing on this. In fact, I mean, it's like if there was water coming in like on this side, it's got 2 layers to where the water would come in, but it would hit this and then fall down. You might get a mist or something that would go inside, but I can't see anything that would be causing it to just refuse to operate. I'm gonna get those 4 screws out. I'll pull this out. I'm gonna disconnect this XT60 connector. Sorry, this is not an XT60. This is an XT90 connector. And then probably cut some zip ties so that I can get everything out. So I've got the 4 screws out. Bit of a pain to get those out with a magnetic screwdriver. Still have to be careful because you've got kind of things in the way where you could still drop that down. The battery is sitting on rails, these metal rails, which are nice. I mean, the whole thing, as far as impact protection, you have plenty of space all the way around, just like in the PowerHouse II 400. Be very careful when you're pulling this out, because I already noticed there's a little tiny wire on this side that's just kind of hanging out, and it goes up to this board up here and goes down to the battery. Like if you're pulling on anything, just watch where you're pulling, because you could be pulling on a wire that could just rip out. It's not as straightforward as the PowerHouse II 400. You know, I should really watch my own videos. Important step that I did not take. I did not remove the screws that are underneath the feet on this unit. So yeah, okay, we're getting there. I was able to remove all of the Celastic. I just took a pliers and just pulled on it. As long as it's between a connector, like 2 parts of the connector, it doesn't have a lot of surface area on the PCB, you can just pull on it and it'll pop off, and that's okay. But if you, let's say around those capacitors down there on the microcontroller, don't try to pull on it, because you could pull up the solder mask or damage the printed circuit board. You don't want that to happen. It's bad news. I got the BMS disconnected. It is pretty nice here where they do have everything labeled. There's red connectors here. Actually, I don't know what they mean, but there's F plus, F minus going into this Amphiol connector. What are these? XT30s. So it's going into this XT30 connector, and there's another one going into this, another XT30 and another XT30, but they reverse the mating on them and then reverse the orientation. It's more difficult to plug the wrong one into the wrong socket. But I wanted to get a picture of this so that I could see which one was which when I go to reassemble it. So now I'm taking all these off. It does seem like there was a bit of a shift here in the construction to where there are, it looks like some part of the MPPT solar controlling is actually back here. Also, there is a raceway. It looks like this plastic piece that I was kind of complaining about before is a raceway for wires. So I guess they put something in there to make it for that purpose. So I'm gonna keep pulling this thing out now. Wow. There is a cover that is held on by a little plastic retainer here that just removed 2 Phillips screws on, pop that off, and this plastic piece comes off. Here you have the combination of things it looks like. You have the output here. This goes to the 2 outlets, the 500 watt output, but this really appears like it was designed with being able to support higher outputs, and I think they just kind of kept it at 500 watts. Because the first clue is here. You've got 3 40 amp fuses in parallel, 120 amps at battery voltage. Okay, so what it looks like actually is it's split there. There's actually, I think it's 2 by 40 for 80 amps, and then there's another 40 here separate for something else. Or it might be, yeah, it might be all together. I'm not quite sure there, but it seems more likely that it's 2 of them in parallel, which would bring this up to about 1700 VA maximum, which is quite a bit more than the 500 watt output would suggest. But the wiring coming out of here looks like it's more for just the 500 watts that are then split down there to go to each outlet. Everything electronic is on top, which is nice, with the exception of the control board down there. I'll get to that in a second because that's a whole thing. I don't see anything that readily looks like it's been damaged, affected by water or anything. The battery is disconnected. Very important thing to note. Those two connectors there go between the battery itself and the inverter side. So I got this whole thing flipped around and got everything plugged back in again. What I did off camera is I did a test of this whole thing to make sure that it works. And surprise, it does. It's not my best guess is that the BMS did not like the state of charge of the batteries, and one of the batteries went under its minimum voltage and it just said no. It shut off power from the battery to control anything. Now, if you plug something into it, like the DC socket here, it'll try to power up the front end of the system. But if the battery management system is like, no, you can't do this, then you're gonna get this weird kind of where it's between the BMS turning on and allowing it to charge or the BMS saying no, yes, no, yes, no. I feel like that's kind of what's happening here. Not the best, but I do feel like with a full charge, it should resolve itself. Since I've tested this, it's charged up to about 10%. The issue that I was experiencing has been resolved. So let's look inside here and see where all these connectors go to. So this one that's labeled C+, C- is for the car socket. You can see it goes off there. I like the addition of a temperature sensor on the car socket, so if you have a crappy device you're plugging in, like say the kettle that I had that destroyed the internal fuse, but didn't blow the fuse, and suddenly made the whole thing get the barrel, the car socket got really hot and then melted the solder joints on it, and then I had to go back and resolder them. That it has a temperature sensor on there and will hopefully shut off before it gets too hot. Now there are then these two connectors, one marked F+, F-, and then G+ and G-, and they're coming from the same spot. You can see down there. And I feel like one is for the Anderson plug and one is for the AC input plug. And the reason why I think that is because I believe the Anderson port has different ratings than just the straight DC input, and it has a higher power handling capacity. The battery management system is not on the front side of the board like on the PowerHouse II 400. There's nothing here. It's actually underneath, which I think the PowerHouse II 400 had as well. It had like a board on the front and on the top, but this has the whole thing on the top. Up here at the top, this connector runs back to control the backlight. This one controls the side little like flashlight thing. And then this one does communication back to the main board here in front of this fish paper, which is all I2C. So that's what those connectors are for. We've talked about these connectors. And then obviously the main connector here with this 8-gauge wire. That's crazy. And it comes into the board here and it is split up between the AC side and the DC side. This then marshals what it's going to route back to this board, which I really can't, I mean, it's so much stuff here that I really can't see, but it looks like it does stay on the primary side and gets over to this card and then it gets powered out, provides power out to everything on this side of the board, protected by that 40 amp fuse. These two here are for the, I believe, for the AC conversion. So DC to AC, it seems like it does it in one step. And it probably can do that because it is running at 21.6 volts instead of 14.4 nominal on the PowerHouse II 400. The PowerHouse II 400, if I remember correctly, had like a primary step up and then it had a secondary that it was boosting it to provide the pure sine wave output. Here it's doing it all, I think, in one step. It's creating high voltage DC all the way through here because this is another high voltage capacitor. And then these are high voltage capacitors. These are all 400 volt, 220 microfarad. And so these are coming through here. I mean, you have a common mode choke, some filtering, and then right at the end stage, they're doing all the switching to basically to make this a pure sine wave output. And then there's your pure sine wave output. Looks like they had some locations for more Y caps, but they decided not to fit those out. There is one here. There was a bunch on the PowerHouse II 400, which I was a little surprised of why they were there. If there was like a grounding screw on this, when you were using it in the battery mode to provide an AC output, and you wanted to ground this whole chassis, then I could see where the Y caps would come into play, but I don't see why they would come into play without having any sort of external grounding, which this doesn't have. Not even when it's plugged in to mains AC. There's no external grounding because it's all on an isolated supply. This is the main supply here. If you're charging it with this brick or the Anderson plug or a solar panel or a car socket, all of which are safety extra low voltage supply, an SCLV supply, which has no ground. There's no earth ground on this. It's just DC positive and negative. That's it. So it's an interesting construction, and I can see perhaps why they decided to omit this. Yeah, so what I want to do now is, actually what I'll do first, I was going to say we'll test it out. We will test it out before I reassemble it. I did do some quick thermal imaging on it. I'll throw it up here. Nothing seemed to get hot while it was charging except for this relay here, which was to be expected again because I was suspecting that the input was coming through this connector, the F plus and F minus connector. It only got up to about 52 degrees Celsius. A little warm, but it's DC, and it's DC at 5 amps. So these relays, I can't really get in there to see what their ratings are. They're pretty small, and I can see that they're rated 16 amps at AC voltages, but I don't know what they're rated for DC voltages. I don't think that's too high of a temperature. I mean, these are probably 105 to 130 C rated relays at least. So getting up to 50 C is not a big deal. Let me flip this thing back around again. Now we're looking back down at the top of this thing. I guess what I'll quickly describe is this harness here that I think came right out of the, I'm pretty sure it's in the PowerHouse II 400, some form or fashion. This seems to really just control what things are being turned on and off and communication between the front panel and this panel. It's not critical communication. That is handled by this connector here directly to the battery management system. If this gets disconnected, then things stop working. This, I disconnected it while it was in operation. It doesn't seem to matter. You just couldn't turn on any other functions. So when I tried to turn on the car socket or try to turn on the AC outlet, nothing happened. Once I plugged it back in again, everything was fine. Really, this is only for just like command and control. And then that plugs into this board, which is then responsible for managing and marshaling the output to either charge things or provide power to the front of the board for USB-C, USB, the car socket, and not the outlets because the outlets obviously come through here, or if there's an input from the Anderson plug. So that's what this card primarily is, its function. This board here, this might be the main microcontroller for the inverter board. It's just on this riser card, which is interesting. So I'll just get that screw out. You're not plugged in. There are 5 screws in this printed circuit on this board. So make sure you get out all 5. They're like on the 4 corners and then one right in the middle. And this lifts straight up. And I will place it. Oh, the fans are connected still. That's right. The fan is connected to this, so I'm just going to slide it over. I'm not going to disconnect the fan. So we look at the bottom of this board. You can see the riser is all that, the microcontroller and all the supporting components look like they are directly responsible for driving all of the inverter functionality. You can also see the separation here, this massive separation, which kind of bends down a bit here, but there is separation here between the battery input, which is right here, and where no, these 3 fuses are actually all together. There's no split. Is there? No, there's no split in that track. So those 3 fuses are all together in parallel. So that's 120 amps in parallel. Yeah, I'll have to do the calculations on that. That is way more than I thought it was going to be. Again, the PowerHouse II 400 for reference had 1 40 amp fuse. So that's beefy. Kind of explains why this wire gauge is so massive. Anyways, there's no controller on the bottom here. This is some logic stuff perhaps down here, but not any like main controller or anything like that. So that would explain that this riser card and that going off in that direction, and why they needed to do that, because they needed to maintain the creepage and clearance distances between the high voltage side and the low voltage side of the board. This is a nice shot actually of these FETs, which are all ST parts. I'll put down on the bottom what those are rated, but that's those look legit. Little ferrites on the, I think that's the output leg. Anyways, moving on. This is the battery management controller. And again, it's manufactured by Blue Way, similar to what we saw in the PowerHouse II 400. This actually is a little different configuration because it's 21.6 volt nominal. You can see what it says battery 1, 2, 3, 4, 5. So we have 5 batteries in series. I don't know which way they're running these batteries, but I feel like, yeah, I can't really, oh no, they're grouped together in just however they did it with the tabs on top. I thought perhaps it was in a row, because I could kind of see this way. You've got the 2 terminals here coming from the battery output. With those are well screwed down into posts, which is nice. I like that it has the E-fuses again, like we saw on the PowerHouse II 400. A lot of silicone adhesive placed around here to keep critical things sealed. I think these are all the output FETs, which you'd want those not to be covered because they get quite hot, especially if it's dumping, I don't know, what is that, 2700 VA, 2500 VA? If it's 120 amps at 21 volts, I mean, that's a huge amount. I can't do math in my head right now, but it's a lot. I'll put it down in the lower third. And then it has temperature sensors. I believe I saw 3 temperature sensors, which is nice. Now I lost track of where I saw it. Oh, there it is. I saw the pads here where there's T1, T2, T3. You can see where there's a temperature sensor there, temperature sensor there, and then there's a third one. Oh, here, right here. It must go inside because it doesn't just readily, oh, maybe it's right there under this like really thick tape. And it has 2 fans, one at the top here to cool the inverter and all the other related electronics, and then one at the bottom to cool all the rest of the batteries, which is a little strange that it's just 1 fan here because it's got quite a wide distance of batteries to cool, but it has a small outlet, so I'm imagining it does get some flow around to all the batteries to keep things cool, and if it gets too hot, it shuts off. But let's look at the cells for a moment because they're different. They're not 18650. Well, that's what they are. Maybe I can get a shot. Now the fans on the other side, they made it pretty difficult to read what the batteries are. There's actually 6 in series. Yeah, there's 6 in series by 8. So it's a 6S8P configuration. 6 in series, 8 in parallel. And that gives you your 48 cells. It's weird. It seems like it's double the size of cells, but not double the capacity. Well, maybe it is, because I think the PowerHouse II 400 is 377 watt hour, and this is 760 watt hour. So both are not quite 800 watt hour. Editing this video has been quite the challenge. So I'm going to leave it here for now, and I will pick it up in the next video. So thank you for watching, and I will see you in the next one. Take care.